Hey, what's up, folks? Today I want to do it like a little example problem that sort of takes into account like the Venturi effect and just shows us basically what's at play with the Venturi effect. So I have a little setup here, right? And this is basically the same pipe of different diameters, and you'll see what I mean in a second. Um, Let me make these a little bit more evenly spaced out. Yeah. So like this is pipe 1, 2, 3, 4, right? And maybe as we go down, right, we have different diameters. So like by the time we get up to pipe 2, we've come to a different diameter. Maybe by the time we get to, okay, let me draw that a little bit better. By the time we get to pipe 3, it's a different diameter, and by the time we get to pipe 4, it's a different diameter, right? So what does that mean, right? We have diameters that are varying with these pipes, right? And so the book sort of drew it like this. And okay, there's one more thing I should add. The water is flowing in this direction, right? So the book sort of drew it like this. Obviously, there's a varying pipe diameter here and here, but I could not tell right off of the bat just by eyeballing it which one was like lower and which pipe diameter was wider and which pipe diameter was lower. And by diameter, I mean like this is the diameter, right? This is the diameter here, right? So it's varying as we go. And they were basically they said like, okay, so water is flowing in this direction, right? In which of the pipes, in which of the vertical pipes will the water level be the lowest? So what does that mean? If you look at the video I did on the Venturi effect, we know that varying pipe diameters can give us because we're in steady flow here, right? The water is being replaced as it is being used, right? That's going to affect the level of the water in each of those pipes. So they're asking in which pipe is the water level the lowest. So so I like to tackle things with logic at times, and just right off of the bat, I said, okay, well, my guess is that because these two, yes, they're different levels, but I can't tell how far apart they are, right? And this is the MCAT, right? They don't want you to spend too much time on every single problem. So I'm gonna say, okay, I'm just gonna take a guess and say it's neither one of those pipes because like there has to so clearly, right? Diameter of the pipe is what's gonna affect the water level because there's nothing else, right? All of these pipes are the same size here, the vertical pipes, right? This water has the same level of this water has the same like it's the same flow rate over all of them, you know? So it has to be something to do with the varying levels of the varying diameters, right? So I'm going to already eliminate 1 and 4, right? So I'm going to say, okay, but let's even say it wasn't 1 and 4, right? I can still figure it out, right? Or let's even say like I couldn't eliminate 1 and 4. I could still figure it out, right? Because I know that it's only going to be an extreme that is going to contribute to the highest or lowest level in these pipes, right? And what do I mean by that? This pipe is definitely not the highest, not the biggest diameter. It doesn't have the biggest diameter or the smallest diameter, this part of the pipe, right? I know that that's not going to give me the highest or lowest water level because I need an extreme. Either it has to be the biggest diameter or the smallest diameter, which would give me the lowest water level in the pipe. So I'm going to say, okay, let me just go ahead and eliminate 1 and 4. Regardless, my logic is going to add up, right? I can examine 3 and 2, and I can say, okay, so it'll show me that as the pipe gets bigger, either the water level gets higher or lower. So I can apply that to whatever I need, right? So right off of the bat, I'm just gonna take a guess and say that it's 2, simply because, right, this is not the biggest pipe. This is not the biggest diameter out of all 4 of these, right? However, right, this definitely is the smallest diameter. And because it's the smallest diameter, right, I can't tell the diameter of these two. This is in the middle, which is not an extreme. So I'm going to take a guess and say that it's 2. But so that's what I would do if I absolutely needed to guess with this problem. But here's what I'm going to do if I really want to figure out, and maybe I have a little bit of extra time to confirm my answer. Because I know that there's a pipe flowing, right? I know it's steady state. I'm going to take into account the continuity equation. And what does this say? So I'm going to choose this as my control volume. And what does that mean? I'm just looking at this area, the water flow in this area, right? So I'm basically sequestering off like pipes 2 and 3, or the area 2 and 3, I'll say. And I'm looking at the continuity equation. So I'm going to say Q2 equals Q3. But what does that mean? It means A2 V2, and I'm just going to do that to the V to make sure we know its velocity, equals A3 V3, right? Okay, what does that get me? So now I'm just going to take a look at A2 versus A3 and V2 versus V3, right? Now, let's think. I know right off of the bat that A2 is smaller than A3. So what does that mean? If this equation has to remain true, that means the V2 needs to be larger than V3 for us to maintain that constant, right? Sorry. Because as A gets smaller, V is getting bigger. Or as A gets bigger, V is getting smaller, right? So that's what we have there. And I also want you to remember something called the Bernoulli's equation, right? So in this situation, Bernoulli's equation is going to say P2 plus 1/2 rho V2 squared plus rho GZ, well, I'll say H2, and that's the same thing, it's just depth. You'll see it represented as Z sometimes represented as H, equals P3 plus 1/2 rho V3 squared plus rho GH3. And what are we saying here? This is just basically saying that the pressure I'm looking at on this side has to equal the pressure on this side. And it's good to sort of know, if you look at my video on Bernoulli's equation, it'll make a little bit of sense. But this right here is called the dynamic pressure, right? This right here, you might, so I'm sure you've seen this equation before, right? Delta P equals rho G delta H, right? That's sort of where it comes from. So when you add these two pressures up, right, this becomes the static pressure. So that's just good to keep in mind, right? But now, right, I'm trying to, with what I like to do with Bernoulli equation is see how much I can cancel things out, right? So here's what I'm going to do. I'm going to say that, okay, well, I'm going to look at 2 points within this control volume here, right? I'm going to make sure that they're the same height. And I'm just doing this to keep as many things constant as possible, right? Let's say I choose those 2 points to look at, right? I know that my depth here is the same, meaning that with this Bernoulli's equation, my H2 equals H3, meaning that I'm able to just algebraically cancel these out, right? So now what does my Bernoulli's equation look like? P2 plus 1/2 rho V2 squared equals P3 plus 1/2 rho V3 squared, right? Okay, cool. Now, what am I going to do here? Now what I want you to do is look at this as a single term and this as a single term and do that on both sides, right? Now, I already said that V2 is bigger than V3, right? And what does that mean? Because my V2 is bigger than V3, I know that my 1/2 rho V2 squared has to be bigger than 1/2 rho V3 squared. How do I know that? Well, looking at this 1/2, it's a constant, right? This rho, technically it's a constant, right? Which while rho does change from uh, uh, substance to substance, right? This is, I don't know if I mentioned this at the beginning, but it's water. Okay, so water is flowing through these pipes. Now, right, because this rho is the same as this rho, right? I know that the only thing affecting how big this is compared to this is this V2 squared or V3 squared. If V2 is bigger than V3, which is what we've said here, this whole term is going to be bigger than this whole term, right? So now I'm able to look at the relation between P2 and P3. Now what does that tell me? If I want this whole equation to remain true, as this goes up, this needs to go down, or as this goes down, this needs to go up, right? So that being said, if I know that this right here is bigger than this, I know that this has to be bigger, no, this has to be bigger than this, right? So now, or I'm sorry, this has to be bigger than this. So now, right, I know, actually I don't know if what I just said is correct, but here I'll just say the whole thing out. If I know that 1/2 V2 squared is bigger than 1/2 V3 squared, I know that P2 has to be lower than P3, right? So this is what remains true. That was ugly. This remains true, right? So P2 is going to have a lower water level. So like let me just extend these a little bit. I know that P2 is going to have the lowest, and I'm just going to move this down. And move this down. Ugh. Move this down. Move this down. Right? P2 is going to have the lowest water level of all of these, and that's just me drawing the water level, right? I know that P3 maybe, depending on how much the velocity difference is going to be higher. I don't know how much higher, unless they give me the velocities and stuff. That much. Why? Because this P right here is our absolute pressure. And that's what determines this whole height in the water column, right? That's what the key to understanding this problem is absolute pressure. So once you know the absolute pressure, or once you know what it is relative to the others, you're going to find your answer, right? Likewise, these might end up being, I don't know, maybe something like up here. They'll probably be pretty similar if they have the same diameter or close to the same diameter, right? So that's what that's going to look like. But remember what my guess was? I guessed that P2 was going to be the lowest, simply because I didn't want to have to eyeball these two. They would never make me do that. And I needed an extreme, right? This is not my extreme. This is somewhere in the middle of the total size diameters, the total diameters of all of the pipes. So that's the way I would sort of tackle this problem, and hopefully it would get me the right answer most times, you know. So as always, please don't forget to like and subscribe. If you have any comments, go ahead and leave them in the comment section. Ask any questions. Maybe you were a little bit confused on anything that I said. So hopefully I'll be able to answer whatever questions you have. So thanks for watching, and let's keep learning. Okay, bye bye.